Up to this point, when we've tried graphing equations, what we call linear equations, we've had equations like the two that I'm showing on the screen right now. And the equation in the orange, just to review this, remember what we did. If we wanted to graph this equation, we made up an x and y table, and we put numbers in for x, added 1 to that number, and that would give us y. So for example, if I put 0 in for x, 0 plus 1 is 1, so y would be 1. And I'd have the ordered pair 0, 1. So when x is 1, y is 1. Or excuse me, when x is 0, then y would be 1. Another example for or another ordered pair would be, how about if we put 1 in for x? Now 1 plus 1 is 2, so y then would be 2. So another ordered pair would be 1, 2. So when x is 1, y would have a value of 2. And usually we say that a recommendation is to find 3 ordered pairs. So let's find one more. Let's put a negative 1 in for x. So when x is a negative 1, let's see, a negative 1 plus 1 is 0. So y would be 0, and I'd have a negative 1, 0. And then when we graph this to check to see that we've done this right, we should have a straight line, or in other words, a linear equation. Now in this example, we put numbers. Notice that the y was by itself. So this equation was solved for y. And we put numbers in for x to figure out what y is. Now on the equation on the right, and I'm not going to set up a table on this, notice this one is really kind of the opposite. In this one, x is by itself. The equation is solved for x. So on this one, we would put numbers in for y, take the opposite of that, and add 2. And let me just do one example with that. So if we, I'd use the same xy table. So if we put numbers in for y now, because then we'll take the opposite of that, add 2, and that'll give us x. So if I put in, say, 0 for y, what's the opposite of 0? 0. What's 0 plus 2? 2. So x would be 2, and my ordered pair is 2, 0. So in this situation, we're filling out the right side of the table. Let's just do one more. How about if I put a negative 1 in for y? The opposite of a negative 1 is 1, and 1 plus 2, well, x would be 3. So when y is a negative 1, x is 3, and we'd have the ordered pair 3, negative 1. And then we'd graph them. Now, what makes these two equations really easy to graph is that both these equations, one of the letters is solved for. On the equation on the left here, it's solved for y. On the equation on the right, it's solved for x. And that's what makes these very easy to set up an x and y table. Let's take a look at example 1. Now again with a topic, this topic is called rearranging before graphing, and it's called that for a reason. Let's take a look at examples. So I have 3x plus 2y equals 4. Now notice in this equation, the equation isn't like the others. We don't have x equal to something or y equal to something. So what we need to do is we need to solve one of these equations for either x or y. And it really doesn't make a difference which one we solve for. Usually we like to solve an equation for upcoming sections. We like to solve equations for y. And there's a reason for that, and I'm not going to get into that right now, but there is a reason for it. So let's solve this equation for y. All right, so what we'll do, I'm going to rearrange it a little bit before I do anything. So I'm going to write this as 2y plus the 3x equals 4. All right, now let's solve it for y. Let's see, they're adding 3x, so we're going to subtract 3x. And they cancel. So I have 2y is equal to 4 minus 3x. Now I almost have this solved for y. Now they're multiplying by 2, so I'm going to divide everything by 2. Remember what you do to one, you got to do to all of them. So you have y is equal to, well let's see, 4 divided by 2 is simply 2 minus 3x over 2. Alright, now I've solved it for y. I'm going to make an x and y table now. Now, the easiest number, I need to put numbers in for x. So the idea here is I'm going to put a number in for x, multiply it by 3, and then divide by 2. Now here's where it takes a little careful choosing of numbers. When I multiply that number by 3, I want to make sure that I can take that product and divide by 2. So in other words, I want the 3 times whatever x is to be an even number, so it divides evenly. I don't want to come out of this with fractions. So let's start with 0. Let's see, 3 times 0 is 0. And what I'm going to do here is I'm going to write this in a different color. So you have y is equal to 2 minus. Now, 3 times 0 is 0. What's 0 divided by 2? 0. So, y is equal to 2. So one ordered pair would be 0, 2. Okay, let's try another one. Now, I don't want to use 1. And here's the reason. If I put 1 in for x and multiply that by 3, I'd have a situation where I'd have something like this. Let's see, 3 times 1 is 3, and then 3 divided by 2. Well, they don't divide evenly, and now it starts getting a little messy because you get fractions or decimals. I want to get a top number that's even. So I'm not going to use 1, I'm going to use 2. So let's put 2 in for x. So I have y is equal to 2 minus. Now, 3 times 2 is 6. What's 6 divided by 2? 3. And what's 2 minus 3? Negative 1. So another ordered pair would be 2, negative 1. Now what would be a good third number to put in for x? I want whatever number I put in for x, when I multiply it by 3, to get an even number. So, and you can have negatives. Let's put a negative 2 in. So y is equal to 2 minus. Now 3 times a negative 2 is a negative 6. Let's see, a negative 6 divided by 2 is a negative 3. So what's 2 minus minus 3? 2 plus 3, or in other words, 5. Now I have 3 ordered pairs. I would check it by graphing it. I'm not going to show that here, but you'd graph it and you should get a straight line, or in other words, a linear graph. All right, last example I have is example 2. Now in this one we have y minus x equals 0. Now as I said in example 1, usually we'd like to solve the equation for what letter? And the answer to that is y. I'd like to solve this for y. So let's get y by itself. Let's either subtracting x will add x. So y, let's see, 0 plus x is just simply x. Right, now this is pretty easy one to make up a table for. So I make up my x and y table. I'm going to put numbers in for x. Well, suppose I put 0 in for x. Well, what's going to happen here? Whatever I put in for x is what y is going to be. So if I put 0 in for x, then y equals 0. If I put 1 in for x, y equals 1. If I put a negative 1 in for x, y equals a negative 1. So I have these ordered pairs. And that's a 1 there. And when you graph these, again, you should get a linear graph. Now I just want to take, I know I said this was the last, I do want to do one more. And let me think of, let's see here, let's use, how about if we have the equation 2x minus 3y equals 6. Now let's solve this for y again. So I'm going to rearrange the left side so that I have the y term first. So it's a minus 3y, and then the positive 2x equals 6. Now solve it for y. They're adding 2x, so we're going to subtract 2x. So a negative 3y equals 6 minus 2x. Now how do I finish it off? They're multiplying by 3, so I'm going to divide everything. Or excuse me, they're multiplying by a negative 3, so I'm going to divide everything by a negative 3. So these cancel. Let's see, 6 divided by negative 3 is a negative 2. Now, notice here I've got a minus minus. So really whatever that simplifies to is going to be a positive answer. And it'd be a 2x over 3, like so. Now, you got to consider what numbers you're going to put in for x. you want to put numbers in for x so that when you multiply them by 2, they'll divide evenly by 3. Usually 0 is always a nice number to use. So I have y is equal to a negative 2 plus, let's see, 2 times 0 is 0. 0 divided by 3 is 0. So y would be a negative 2. I don't want to use 1 because 2 times 1 is 2, and 2 doesn't divide evenly by 3. I don't want to use 1, so maybe 2. So let's show that. So if I put 2 in for x, y equals a negative 2 plus, let's see, 2 times 2 is 4. Actually, my mistake. 2 isn't a good number because 2 times 2 is 4. 4 doesn't divide evenly by 2. So what could we use for x that would divide evenly by 3? Let's use 3. Because y is equal to a negative 2 plus, let's see, 2 times 3 is 6. What's 6 divided by 3? 2. Divides evenly, right? And that would give me 0. Now another good number might be a negative 3. Let's see. So when I put a negative 3 in for x, I have y equals a negative 2 plus, let's see, 2 times a negative 3 is negative 6. A negative 6 divided by 3 is a negative 2, which would give me a negative 4. And then I graph them, and I should get a linear graph. So this section is called rearranging before graphing.